So today we are starting with a new topic, that is the polymer. So the first question comes into one's mind that what is the meaning of a polymer? Okay, so let us just look into that. So the basically polymer means the macromolecules. Macromolecules means the large molecules. Macro means the large. Okay, so the polymer are the macromolecules. Macromolecules whose weight they varies from 5,000 to the millions, whose molecular weight they varies from 5,000 to the millions. That means we are going to have the large molecules. Now, of what thing these large molecules are being made? These molecules, they are made up of the monomeric units. Okay, so they are made up of small units called the monomers. Okay, so what is the actual meaning of this? Let us just have a look for that. So suppose this is our polymer where large number of the repeating units we are having. So here AA is combining to give me this long chain of this monomer unit is there. That means this big unit is called as the complete polymer. Okay, and the large number of the molecules are there in this. That means it is a macromolecule whose molecular weight is going to vary from 5,000 to the millions. You can just imagine that how big these molecules are. Okay, so the repeating unit in this example that we have taken here, the monomeric unit, that will be A. So here the monomer is A. That means the repeating unit whichever it is, that is the monomer. Okay, so let us have a look for other ones also. Suppose this is my other polymer example. Okay, so here a large number of the chain is there, that n number of the molecules are combining. So here what is our repeating unit? That is our AB. AB is the repeating unit. So AB is the monomer here. So whenever we have to look for a monomeric unit, we just have to see that which of the units is being repeated in that complete polymer. That in that repeating unit, that is going to be known as our monomer. Okay, so I have written a definition for this. That is, a polymer, it is a macromolecule that is formed by the large number of the simple monomeric units. This is what we have seen, that are repeated over and over again. That means they were repeating over and over again, okay, to form a macromolecule. That means to form a large molecule. Okay, the monomeric units, they are joined together through a covalent bond. Okay, so here you can see a single line that I have marked between the two monomeric units, that is AA, or either AB unit and the AB unit. They were joined together through a covalent bond. Covalent bond means the bond that is formed through the mutual sharing of the electrons. This you might have studied in your inorganic or in the basic classes also. So these monomeric units, they are joined together through a covalent bond. Okay, I hope now the definition of the polymer, it is clear that it is a macromolecule that is formed by the small repeating units that are known as the monomeric units, and these monomeric units, they are joined together through a covalent bond. Okay, I hope this much is clear. So the next thing is about the degree of the polymerization. So how many monomeric units are present in that polymer, that we need to find out. That is given us with that is known as the degree of the polymerization. Okay, so this is denoted with the capital P. So what is degree of polymerization? So the number of the monomeric units that are present in a polymer, that we can find it out. So the number of the monomeric units present in a polymer is degree of polymerization. Okay, now how this degree of polymerization, it can be calculated. So it can be calculated as the ratio of the molar mass of that complete polymer upon the molar mass of that monomeric unit. So here degree of polymerization will be molar mass of our polymer. That means the large chain, that big complete unit which you are having upon the molar mass of the monomer. Monomeric means that small repeating unit whichsoever it is present, that unit. So dividing both of these, that is the mass of the polymer upon the mass of that monomer, is going to give me the how many number of the monomeric units are present in that polymer. Okay, so that is known as the degree of the polymerization. Okay, so now next thing is the classification of these polymers. Okay, so how these polymers they have been classified. So before looking into that, let us have a look at how these polymeric units they are being formed. Okay, so here the most common example of the polymeric unit is our PVC. That is used in our Teflon. That utensils are being made up of polyvinyl chloride, and the polythene, that is the other example, the basic one that on daily basis we are making use of. The polythene that is made up of the small monomeric unit, that is our ethylene unit. Okay, so that means here large number of the CH2 units, that is n number of the CH2 units, they are going to combine to give me the polythene. Okay, so how they are combining, that this CH2 they are combining with the other units. Okay, so the n number of the such units they are going to combine on either of the sides, and we are going to get as the polymer, that is our polythene. Okay, this is our polythene. Okay, so the other one that I told was the PVC, so that is our polyvinyl chloride. Polyvinyl chloride. So the monomeric unit here we are having is the vinyl chloride, that is our CH2 double bond CH2 CH, and the Cl unit is present. Okay, so the n number of these units they are going to combine. So when they are combining, we are having is CHCl. Suppose CH2 and the CHCl is repeating like this only. Okay, so here and this so on, this chain continues and so on. So here you can see that we are getting the chiral centers, or we can call as the asymmetric centers. Here these are the asymmetric centers that are being formed. Okay, so based upon the chirality that is going to be present at these asymmetric centers, these polymers can be classified. Okay, so the polymers can be classified on the basis of their chiral centers, on the basis of the chirality at the asymmetric centers, we can classify them as three of the categories. For this they are possible, that is our isotectic polymers. The other is called as the syntactic, and the third one is the atectic polymers. So on the basis of this three categories they are possible: syntactic polymer and the isotectic polymer. So the word iso means the same. That means at all the chiral centers that have been formed during that formation of that polymer, the same configurations of the D and L configuration is present at all the chiral centers. That is known as our isotectic polymer. Okay, so let us just have a look for that. So suppose this is our polymer. Okay, and here we are having is these are chiral centers. So at all the centers, this chirality that we are having is the same one. That means either all of these they are having the configuration as the D or the L configuration. So this type of the polymer, it is known as the isotectic polymer. Okay, so the other one that I told you is the syntactic. What is the meaning of this syntactic polymer? It means when the alternate chiral centers, they are having the same configurations, either at the alternate positions. That means, suppose this is our polymeric chain. So at the first position, suppose it is at wedge, and this is at R. So here it is at wedge again, and here it is R, and the chain it continues like this. Okay, so that means at the alternate positions we are getting the same configurations, that is either the D or the L configurations. At the alternate positions they are same, that this is known as our syntactic polymer. Okay, so this is our syntactic polymer. Okay, and the third one, that is atactic polymer. It means that the random configurations is present at the chiral centers. So here, suppose this is our polymeric chain. Suppose the first one is at R, the second is at wedge, then again it is at wedge, sorry, dash, and this is again the dash only, and suppose here it is wedge. That means a random configuration of the D and L is present, D or L is present at the chiral centers or the asymmetric centers. So this type of the polymer, it is known as our atactic polymer. That means the configuration, it can be either of them at any of the centers. So here it is, this is our atactic polymer. So this was the classification of the polymers on the basis of the configurations that can be present at the chiral centers. So based upon that, three of the classifications are possible. The first one, that is isotactic, that means same configurations is going to be present at all the chiral centers. Next, second one was the syntactic, alternate positions the configuration is the same. And the third one, that is the atactic polymer, in which the random configuration is going to be there at all the chiral centers. Okay, so now let us have a look for the other classification that is possible, that is on the basis of their existence. Okay, so there can be natural polymers. Natural polymers means the biological polymers, you can call, like proteins that in our body they are present, proteins and the polysaccharides. So proteins, basic unit of which they are formed is the amino acids. Okay, so that means that are known as a natural polymer, made up of the monomeric units, that are the amino acids. The next one is about the synthetic polymers, that are man-made polymers. Okay, so two on the basis of their existence we have is the natural polymers and the synthetic polymers. Synthetic polymers. Okay, so the natural polymers examples I told are proteins that are present in our body, made up of the amino acids, that are going to be its monomeric unit. Okay, the synthetic polymers means that are man-made polymers. Man-made polymers. Examples for this, polythene, polyvinyl chloride. Okay, so all these, they are bakelite. So these all polymers, they are the man-made polymers. Okay, so these man-made polymers, they can be further classified based upon the processes through which they are being formed. So the further classification of the synthetic polymers we have is as synthetic polymers, so they can be as the addition polymers and the condensation polymers. So we have is the addition polymers and the other one is the condensation polymers. So what is the meaning of the addition polymers? So these are the polymers in which the monomeric units, when they are combining, there is no loss of any small molecules. Small molecules means like the water or the any other small units like the ammonia or like such. So they are formed generally through the free radical mechanism. So here addition polymers. So here monomeric units, they combine through the free radical mechanism, and in the condensation polymers, they are combining through the step growth mechanism. So here the monomer units, they combine through step growth mechanism. Okay, so in the addition polymers, examples for this is like the polythene or the polyvinyl chloride only. They are the examples of the addition polymers that are formed through the free radical mechanism, and during their formation there is no loss of any smaller units, small molecules. So here further the addition one and the here condensation. The other point of difference between these is there is no loss of small molecules like the water. So in the condensation there is going to be the loss of the small molecules. When the monomeric units they are combining, there is going to be the loss of the smaller units such as the water. So here there is the loss of the small units or the small molecules like the water. Okay, so in the condensation, you can say that it is like difunctionality is present in the monomeric units. So the example for this you can take like one of the acid is combining with the another amine group is present. So during their combination there is going to be the amide